All right, Mr. Ahmed here for 8.3. Goal for today is to prove triangles similar by using side, 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 and side, angle, side. So, first theorem, side, 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 states that if the corresponding side lengths of two triangles are proportional, then the two triangles are similar. So we're going to have to check to make sure that the corresponding parts all have the same ratio in regards to their side lengths. All right, so we're going to start with triangle ABC to triangle DEF. We're going to see if that one's going to be proportional first for our first example. So, is either one similar to ABC? So when I look at AB, I see 8 is the shortest side. And when I look at DEF, 6 is the shortest side. So we will check, is 8 over 6 equal to the longest side of AC, which is 16, and the longest side of DEF is 12. So I'd have 16 over 12. And then we have to check and see if that's going to be proportional to the remaining side. And so I've already used 8 and 6. I've used 16 and 12. My remaining middle side is 12 and 9. So we have to see if those are equal. So 8 over 6 reduces down to 4 over 3. Reduces down to 4 over 3. Reduces down to 4 over 3. So they are all equal to 4/3, therefore they are proportional. So we could state for sure that triangle ABC is similar to triangle, and now I named ABC 8 to 12. So I went the short to the middle. I need to do the same thing, short to the middle, DEF. And now we will check and see if it is similar to the other triangle, HJG. So the shortest side of ABC again is 8. Shortest side here is 8. So 8 over 8 is 1. The longest side is 16. Longest side, 16. That's equal to 1. Middle side is 12 over 10. Those are not equal because 12 over 10 is not 1. So ABC is not similar to triangle GHJ. All three side lengths were not proportional. For the first one they were, the second one they were not. Now a couple key things here. When I matched up the shortest sides, just kind of circling back here, 8 corresponded with 6. The longest side was 16 and 12, and the remaining was 12 and 9. So that's kind of how I set those up and then reduced the fractions. You could use a calculator if you'd want instead. Next one says, find the value that makes find the value of x that would make the two triangles similar. So I'm just going to state that AB corresponds with DE. We're good there. So 4 over 12 would have to equal the one that has the x in it's here on the bottom. So 8 corresponds with that. 8 over 3 times x plus 1. Now I'm going to distribute this first and make that a 3x plus 3. Now I can cross multiply to solve. 12 times 8. Need my calculator for that. 12 times 8 is 96. Equals 4. Oh, I forgot my plus sign. 4 times 3x plus 3. Almost forgot my plus sign there. Now I can distribute. 96 equals 12x plus 12. Subtract my 12, and we got 84 equals 12x, and then 84 divided by 12 is 7. So the value of x that would make them proportional is 7. So lots of proportions to solve here. Next one, which of the three triangles is similar? So we got to check and see. I'm going to start with this one and check and see if these two are similar. So shortest side of LMN. So I'm going to go short, long, remaining. We'll go here to here first. So the shortest one's 20 over shortest side 24. Longest side 26 over longest side 33. And middle remaining one is 24 and 30. So let's see if those are equal. So 4 goes into both of these. 5 over 6. I don't know of really anything that goes into 26 and 33. Let's check the 24 over 36. 2 over 3, so 12 goes into both these. 2 over 3 is not equal to 5 over 6, and it's not equal to 26 divided by 33. So I'm just going to kind of show you how I could check this with my calculator just a little bit quicker than reducing the fractions. I could check 20 divide 24, 0.833, 26 divide 33, and I can already see that those are not equal. So I would know that it is not going to be proportional. So these two are not. Now we can check these two. So 20 would correspond with 30. I'm going to do that in red. So 20 over 30, shortest. Yep, good to go. Longest side, 26, 39. And the remaining is 24 and 36. All right, again, I'm just going to use my calculator for this. 20 divided by 30. 0.6. 26 divided 29. Oops, sorry. 39. 0.666. 24 divided 36. Those are all the same, so they are all equal. They all reduce to 2 over 3. So we would know that triangle LMN is indeed similar to triangle. Now I named the first one LMN, so that was short to middle. I need to do the same here. Short to middle. So Y, Z, X. And I know that by side, side, side. And I would now know that these two are not going to be similar as well. Since these two were and these two weren't, all three would have to be for it to happen. So I don't really need to check the third one. We're good to go. All right. Our last theorem to show that triangles are similar is side angle side. And what we're going to do is we're going to check that if we have two side lengths that are proportional and the included angle is congruent, then the two triangles are going to be similar. So when I take a look at this here lean-to, it says I'm building a lean-to shelter from a tree branch as shown. Can you construct the right end of, so it's similar to the left end using the angle measures and the lengths shown below. So I need to check and see if this is going to work out. So the first thing I need to do is 9 over 6 and check if that's equal to 15 over 10. 9 corresponds with 6, 15 corresponds with 10. Now, one other way you could check to see if these are similar is you could cross multiply. 9 times 10 is 90 and 6 times 15. Let's see what 6 times 15 is. That's also 90. So you could cross multiply and see if they're equal. Otherwise, we reduce the fraction. Or we could just type 9 divided by 6 and 15 divided by 10 and see if we get the same thing. So we got some options. I'm going to reduce this one. 3 goes into 9 3 times. 3 goes into 6, 2. 5 goes into 15 3 times over 2. They are indeed proportional. The angles are congruent, so yes, the triangles are similar. So I will name the first triangle GPH. Is similar to triangle BAC by side angle side. All right, so these two sides were proportional with these two, and the included angle was congruent. All right, explain how we know the triangles are similar. So the first one, I see we have a congruent angle. Now we have to check and see if the corresponding sides are proportional. So we have to check 24 over 18. Is that equal to 28 over 21? All right, let's take a look. 24 over 18, let's just type it in. 24 divide 18, and 28 divide 21. Those are indeed equal, so yep, that checks out. And we have the included angle that's congruent, so yes, they are similar by side angle side. So we have to check that. All right, next one says triangle XZW and YZX. So this is also 90 degrees here. So I know that we have this 90-degree angle for both triangles. Now the 16 is bigger than the 12 is bigger than the 9, so they're sharing this middle piece. So we have to check and see, is 16 over 12 equal to, notice I went big to small, 12 over 9. And if I want, I could redraw these two triangles to make this a little bit more obvious. So this is W16, ZX, 90, 12. And then the other triangle was drawn like this. Okay. The longer side is 12. The right angle is here. The shorter side is 9. Hence how I get 16 to correspond with 12 and 12 to correspond with 9. And then we got to check and see if those are equal, which I believe they are. 16 divide 12, 12 divide 9. They are indeed. So those are congruent. Come on in. Right there. So they were indeed congruent, or sorry, not congruent, but similar by side angle side. And as we move on to the next one, determine whether ABC or DEF is similar to XYZ. So we're checking to see if it's similar to XYZ. So again, I don't know, let's see here. Let's start going this way. So 18 over 12. Have to check and see if that's equal to 25.2 over 15. So again, that's a little bit tougher to check and see. I don't need to put the other 18 over 12. Well, we'll put that in anyway. 18 over 12 had two congruent sides, so I'm checking here to here first. And let's see what we get. So 18 divide 12 is 1.5. And 25.2 divided by 15 is not 1.5, so those are not equal, so those are not similar. Now we'll check the other one, 18 over 10. And we have another 18 over 10, and then a 25.2 over 14. So we have to check and see if that is equal. So 18 over 10 and 25.2 divided by 14. 1.8, 1.8. So those are indeed all equal. Check it off. So triangle ABC or DEF is similar. So triangle DEF is similar to triangle DEF XYZ. And it's by side, side, side. We got it. Next one, find the value of x that makes the two triangles similar. Make sure that we set this up with the corresponding parts in the correct order. So PQR, so I have to use QR with the x, so QR corresponds with KL. So x plus 2, QR over KL, which is 3, has to equal, let's try and use this 8. QP is 8. And QP corresponds with JK. JK is 4. Okay, so that's probably the easiest way to set that one up. 8 corresponded with 4. And x plus 2 corresponded with 3. And I checked that out using the statement. LKQR. All right, now we can cross multiply. 4 times x plus 2 equals 24. 4x plus 8 equals 24. 4x equals 16. X is equal to 4. And we got it. All right, last one. Show that the triangles are similar and write a similarity statement. Explain my reasoning. So I'm going to take a look at this and draw this bigger one out first. This is EAC. And AC is 15, EC is 12. Now I'm going to draw the little one. B, D, C. We have a 10 and we have an 8. So I redrew these out. Angle C is congruent to itself. Reflexive property. So we can use that. Then we have to check, is 15 over 10 equal to 12 over 8? And this time I'm actually going to cross multiply and check just so I can show you. 120 equals 15 times 8 is also 120. Since those are equal, it checks off. So we can state that they are similar. So triangle, I'm going to name this one ACE, is similar to triangle BCD by side, angle, side. We had the included angle, which was congruent, and these sides were proportional. And that's it for today. Have a good one.